11.9 normal distributions, and this section we'll use the TI calculator, the z-scores, and we'll talk about the bell curve and empirical rule, which is very important to know. Okay, so let's get started. All right, so the normal distribution is talking about a bell curve shape, a curve that's symmetrical. It is called the bell curve because it kind of looks like a upside down bell. The mean, or mu, and you'll see it written, it's like a U but a little fancier. That's mu, or x hat. Okay, x bar, x hat, those mean the mean, which is the average. All right, and it's located on the line of symmetry under the peak of the curve. The slopes going down on either side are at the same rate, so that makes it symmetrical. Each normal distribution has a different mean, or mu, or x bar, or x hat, and standard deviation, which is this little sigma, it's lowercase sigma, that makes it different from the rest, but they're all still bell-shaped. So areas under the curve represent the probabilities of something associated with continuous distribution, the probability that an event will occur. If the entire area under the curve is shaded, the probability is 1 or 100%. Likewise, if only half of the bell curve was shaded, then the probability is 1/2 or 50%. So let me draw in what we're talking about here. All right, I'm going to use a red. All right, so right through here, okay, right through here, as straight as I can do with this particular pen, is going to be the middle of your bell curve, so that this side and this side are equal. Okay, right here will be your mean. Okay, so this would be mu, or x bar. Okay, so your mean will go there. And then each one of these places, well, if I could draw it straight, each one of these places to the side, either to the right or the left, these lines represent standard deviations, okay, which will be the little sigmas. So each one of these are a sigma. And depending on how many sigma that it is away from your mean, we're talking about standard deviations away from the mean, okay? So if everything is shaded underneath the bell curve, it's a 1, probability of 1 or 100%. If only half, it's 1/2 and 50%. Okay, so this is what we'll be doing. You'll need to be making your bell curves and putting in your lines and everything as we go. All right. The empirical rule. This is very, very, very important and very, very easy. If you know this, then you'll be able to figure out most of the probabilities without any problem. This is separated by your standard deviations. You notice I have 3 standard deviations on the right, 3 on the left. This would be your mu, or your x bar, your mean. And this would be 1 standard deviation, 2 standard deviations, 3 standard deviations. This would be -1, -2, -3. And depending on if it's a normal standard or just a standard distribution, then you will have other numbers other than this. But this just lets you know this is the first deviation. And between the -1 and the 1, that would be considered between 1 standard deviation of the mean. Okay, 1 standard deviation, not 2, because it's 1 to either side, within 1 standard deviation. Between the 1 standard deviation will be 68% of your data. So right through here, all this, if you shaded the whole thing in right here, that would be 68% of your data. And of course, because this is symmetrical, you could break each half into 34. So I've separated the pieces for you down here. 68, though, is the thing that you got to remember. All right, now between 2 standard deviations, that would be 2 to the right and 2 to the left. Between that amount right here, that would be 95% of your data that would fall in that bell curve part. And then from 3 standard deviations out on either side would be 99.7%. And the last little piece on the tails would be the rest of it that would round it up to 100%. So what that breaks down to being, and you need to know these little pieces, because this, if you know these 4 pieces, it's also this over here, okay? Because it's symmetrical. This piece right here is 34, hence we have 68. So you could take 68 divided by 2, you'll get 34 and 34. Then we have from here into the next one, the second standard deviation, that is 13.5%. That would also be true over here. And then from the second to the third standard deviation, that is 2.35%. And the last little tail on either side is 0.15%. You must know these, okay? In order to do this stuff, you need to know these. It's not difficult, but you need to know these. So what that means is 68% of the data fall within 1 standard deviation of the mean. 95% of the data fall within 2 standard deviations of the mean. And then 99.7% of the data falls within 3 standard deviations of the mean. Okay? Very important to know, must know. Normal distribution versus standard normal. Okay? I put these over top of one another so you'll see it's exactly the same thing. It's just written a little bit different. Normal distribution uses the actual mean of the data. Say you have test scores and the mean was 80. Okay, that would be the number that goes right here. They use the actual mean of the data and the actual standard deviation of the data. Whereas with a standard normal distribution, it always has a mean of 0 and a standard deviation of 1, always. That never will change. So in the example I did in the front, where I put the mean 1, 2, 3, that is really a standard normal, okay? All right, so let's give an example here. Exam scores have a normal distribution with a mean of 70 and a standard deviation of 10. All right, so the mean always is the very middle line, and that mean is 70. So I'm going to put 70 on my normal distribution. All right, it says a standard deviation of 10. That means every one of these, we're going to add 10 on the right, and every one of these on the left, we're going to subtract 10, okay, in the negative direction. So 70 plus 10 would make that 80. 80 plus 10 makes that 90. And 90 plus 10 makes that 100. Over on this side, 70 minus 10 is 60. That's positive 60. All right. 60 minus 10 is 50. 50 minus 10 is 40. Okay. That would be your mean and your standard deviations to either side. And that's how you would set this up. All right. Now, remember, from here to here is 68%. Okay, this section right here. So if I colored all of this in, this 68%. What that would mean is that score of 60 to 80, any score between 60 and 80 would fall in the 68th percentile. Okay? Any score from 50 to 90 would fall in the 95th percentile. And from 40 to 100, which means almost all of the scores would fall between 40 and 100, and that would be 99.7%. Okay? And if you needed to find little pieces, you just either add or subtract your little pieces together, and you'll get your percentile. Now with a standard normal, remember it says up here, it always has a mean of 0, so that's going to be a 0 right there, and I'm going to put mu or x hat. I could put x bar, doesn't matter, same thing. All right, and that would mean this would be a standard deviation of 1, 2 standard deviations, and 3 standard deviations. This would be a -1 standard deviation, -2 standard deviations, and -3 standard deviations. Okay, it lines up. So if I had a score of 60, that would actually mean that I am 1 standard deviation below the mean, if you're talking about a standard normal. Do you see how it works? If I'm talking about a score of 90, that would mean I am 2 standard deviations above the mean. That would mean that you are 2 standard deviations above the average in the class. Okay, so if you're on this end, you're pretty much above average, and if you're down here, you're a little below or very below. So it lines right up. You just have to be able, in this particular unit, to be able to interpret the graphs. Okay, set them up and interpret the data, interpret the graphs, and be able to answer questions like 80, the score of 80. What standard deviation is that? Is it above or below? That kind of thing. What scores would fall between the 95th percentile, or they could even ask you up to here would be 50% correct, because this would be half. 50% plus, they could say between 0 and 80. Well, that would be everything up to here, which is 50%, plus that 34. So that would be 84%. So you see, you need to know those little pieces so you can answer the questions. All right, so this is the normal with your actual numbers, and this is your standard normal with your just deviations and 0 as your mean. Okay, mostly you'll be working with normal. All right, if you need to convert from a normal distribution to a standard, so in other words, going from an actual score to one of those deviations of 1, 2, 3, that kind of thing, you need to use the Z formula where X is the score. This right here would be an actual score. This is going to be your mean. This is your standard deviation. You calculate that and you'll get a Z score. Okay, once you get a Z score, then you will look it up on our tables that we'll have in the class, and it'll tell you a decimal, and then you move that to a percent, and that's your standard deviations. Okay, so we'll be working with this, but this is your formula for Z scores, where this is your a score you're looking at. This is the mean, and this is your standard deviation. Okay? This formula is on your formula sheet that you'll be given, so you won't have to memorize it. You just need to know how to use it. Okay, so for example, Bob's standard score we want to find. If Bob scores 80, using the information in the previous example where the mean was 70, the standard deviation was 10. So we want to find out what his standard score is, or his Z score. Okay, so we're going to say Z equals Bob's score, which is 80, minus the mean, which is 70, divided by 10, which is the standard deviation. So that would be Z is equal to 80 minus 70 is 10. 10 divided by 10 is 1. All right, so that would mean he would be at 1, and you would look up in the chart and find out what that Z score is. All right, and that's going to be, let's see if I've got one here. Might. Of course, I got the negative one. On your table, you'll have a laminated sheet. It will have positive and negative sides, so you'll have to watch. If it's a positive one, you have to flip it over. If you look up positive 1, that is whoops, I'm writing on the wrong thing, 0.8413. If you look up on the table, okay, 0.8413, and you have to change that to a percent. So that percent would be, keep writing on something wrong here, 84.13%. All right, so Bob's score of 80 is in the 84th percentile. All right, so suppose Bob scores 80 on both his math exam and his English exam. But his math exam has a mean of 70 and a standard deviation of 10, where his English exam has a mean of 85 and a standard deviation of 5. Find the Z scores on both exams and determine which one, if either, he did better on, and explain your answer. So let's calculate this. We've already got the one for the math exam. It's the same information we've got here. So his Z score on math, and I'm going to put math, Z score was a 1, okay, which was 84.13%. All right, let's do it for the English. So that would be Z equals, and that's going to be English. English Z is, his score was 80 on both, and the mean was 85, all over a standard deviation of 5. And when we calculate that, that is going to be negative 5 over 5, which is a negative 1. Okay? A negative 1, if we look it up on our table, and find my negatives again, negative 1 means that equals to 0.1587, which is 15.87%. Now, anytime you score, and you're comparing two scores, this is your math score of positive 1 and your English score of a negative 1, think of your bell curve, okay? And if the average score was 85 on your English exam and you scored an 80, you're over on this side, okay? That's going to be below average. But if you're on the math thing and you're looking at your bell curve and the average was a 70 and you score an 80, that's over on the good side, okay? So that means you're in the positive end. So looking at that, you should easily be able to tell that he did better on his math test because it's a positive 1 versus a negative 1. That means he did better on the math. And of course, because he's a math student, they have to do better, right? All right, so that's what you're going to do. You compare these and looking at these things. And if you need to make yourself a little chart, a little bell curve to think it out, do that. It'll help you a whole lot. I recommend it. Probability. All right, that is exactly what we're figuring out. The likelihood that that event will occur. To find probability, you can calculate the z-score like we just did, look up the probability on the charts, or you can use a calculator. So before we used the charts on the z-scores, now we can do it with calculator. All right, so this will mean you have to have a TI-83 or an 84, and you would go to second bars number 2, and that would be normal CDF. You're going to enter the lowest value, then the biggest value, your mean, and then your standard deviation. There will be commas in between these, just like I've got it here, and it will be in parentheses. And then when you get that answer, you change to a percent. So, for example, Clint sleeps average of 8 hours per night. Standard deviation of 15. Okay? Average is the same thing as mu, and the standard deviation is 15. Or, now remember, 15 minutes is 1/4 hour. We got to make sure we're in the same units, guys. So watch that. Don't put in 15. It's 1/4, which is 0.25. Okay? All right, what is the chance he will sleep less? So each one of these problems, you're going to have to ask yourself, what do I need to know? Less than means numbers smaller than 7.5. Yeah, we know that. But we need to interpret what we get when we get our z-scores, okay? Now, if you want to use the calculator and you do the second bars thing, enter the lowest value. Well, it says, what is the chance he will sleep less than? So it cannot be 7.5. That's the biggest number, right? It's numbers less than 7.5. So when we want to use less than, let me write it up here. We're going to type in first, because this is going to make it smaller, 1 E99, which is your scientific notation. -1 times 10 to the 99. Okay, that is your scientific, that is very, 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 very small. -0, negative, 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 way below 0. Okay, so if we want a less than, that is the smallest number. Okay, then the bigger number will be 7.5. That is the most it would be, because they're asking for less than 7.5. So that's the most it would be. And then you put in your standard deviation and your mean, and then your standard deviation. Hit all that in there just like you see it with the commas. hit enter, and you will get 0.02275, at which point you move it 2 places over to the left to make it into a percent. Now, if you go and do it z-score with the charts, you would put in the number of hours, 7.5, minus the 8 hours, which is the average, divided by the standard deviation. You will get a z-score of -2, which you would then look up on your chart, and it would give you a 0.0228 or 2.28%. Either way, this is using the z-score and the chart. This is using your calculator. Either way you feel more comfortable, do it. But you've got to remember the steps. We can't tell you in a pinch how to put it in. So second bar is number 2. And I just recommend, don't get freaked out with your SOL and your calculator. Punch buttons, okay? You know it's going to end up be around stat or vars, in second stat or second vars, somewhere in there, okay? Just look around for it. And don't freak out, it'll be there. All right, so that's how you do probability. All right, so we are going to be practicing more and more of these in class. We'll be finding a whole lot of them for homework, and we'll be talking about distributions and how all that works out, and we will see you in class. If you have any questions, come see me.